Hello everyone, I hope you all are doing great. Today in this video I'll talk about the IP address one more time, and this is the third video on IP address. So last two videos, the part 1 and part 2, I discussed about the format of IP address, how to convert IP address from decimal to binary, binary to decimal, the length of the IP address or IPv4 address, then the classful or classless IP address, then the mask of the IP address. So I believe you got a very solid idea on IP address based on the last two videos. And today in this video I will focus on subnetting, which is very important concept of networking. So in this video I will talk about why actually subnetting is needed and how we do the subnetting or the equal size subnetting. And then I will show you some example of how we can do step-by-step subnetting. So I believe if you watch this video from beginning to end, you can understand how to do the subnetting, and you will find the subnetting is very easy to do. Okay, so let's see first why actually subnetting is needed. So if we don't do the subnetting, that means all the computers or all the network devices are in a single IP network, and all of these devices has one IP, one network address or network ID for all of these network devices. So for example, if you consider 192.160.1.0/24 a network ID, that means within these networks we have all the devices connected, and all of these devices are in the same network. So now the question is, what happens if all of them are in the same networks, or what are the issues in this case? So one issue is waste of IP address. For example, consider in this network we have 100 devices, but in this network 192.160.1.0/24 we can have 254 or 252. I mean, more or less we can add that number of devices or that number of IP addresses, right? So we are not using, like for example in this one organization they might be 50 hosts or 50 devices. So if we do not do any subnetting, that means all other devices, all other IP addresses they are not using, they are wasting some of IP addresses. So to reduce the IP address waste, we can also do the subnetting. And then if the network is bigger, that means the same networks, so we can call this whole is a one broadcast domain. So any device send a broadcast message, and that broadcast message go to all the devices in the network. So by doing the subnetting, we can reduce the scope of the broadcast, and that actually improve the performance of a networks. So why we need the subnetting? Actually we want to reduce the waste of IP addresses, because IP address or IPv4 address is very limited, and also we can improve the performance of the network in many different way. Like one is we can reduce the broadcast domain, that improve the performance, or we can also have better management of the security, better management of the networks. So now what is actually subnetting? Very simple, very straightforward. That means if we have a big networks or big set of IP addresses, we want to one network into multiple network, right? So in this example, like we had initially one network, and we are dividing this one network to two networks. So subnet 1.1 and subnet 1.2. Very straightforward. So no complications. So just keep keep in your mind the subnetting is basically we have a big networks and we want to subdivide this network based on the requirement of our organization, based on the requirement of your company. But if we do that, that automatically actually give us some benefit. So it reduce the broadcast traffic, so improve the performance, you can manage the network better, you can manage the security of the network better, right? So now let's see actually how we can do the subnetting. What is the process of do the subnetting? What are the steps of to do the subnetting? So the first thing is, when we do the subnetting, we actually use the host part of the IP address. In my previous two videos, we discussed about the host part and the network part. So to do the subnetting, we borrow some of the bits from the host part of the some of the bits from the host part of the IP address. So if you need to review the host part and network part, you can again go back to the other two videos, the part 1 and part 2. So you can again get the very good idea on the host part, network part, classful and classless. So now again, so the subnetting is the process. The way we do, we actually borrow bits from the host part of an IP address, and the length of the subnet ID is depends on how many subnets we needed, or how many addresses, or what is the number of addresses required for each subnet. That means how many bits required for each subnet. So the two way we can do, one is the number of subnets we needed, or number of address required for each subnet. So consider you have an IP address in class A, and the class A has 8 bits for network address and the remaining 24 bits for host address. So out of this 24 bit, we need X bits for the host, and the remaining 24 minus X is for our subnet. Same for class B. So class B, we have the 16 bit for network address, and if we need X bit for the host, so the remaining 16 minus X is for our subnet addresses. And if it is the class C, so in that case 24 bit for network address. So out of the remaining 8 bit, sum of the bit for, in this case, if we say the X bit for host, so 8 minus X, that is our subnet address. If it is the CIDR or classless, so consider 22 bits is for network address and X bit for host address. So 10 minus X is for your subnet address. So again, so to do the subnetting, we actually borrow the number of bits from the host part of an IP address. And how many bits we need for subnetting, it's depend on how many subnets we needed, or how many bits we need for a network, a subnetwork. Okay, so now let's look an example. So we will see we will do step by step. So consider we have an IP address 192.168.1.0/24, and we need two subnetworks. So if we need two subnetworks, how many bit we need to borrow from the host part? We need to borrow only 1 bit from the host part, because 2 to the power 1 is 2 subnets. So if we borrow 1 bit from the host part, we can get 2 subnets. So now for example 192.168.1, then 8 bit all are 0, and out of this we will borrow 1 bit, and the mask of this network, because /24, so the mask is 255, 255, 255, and all the 8 bits are 0. We also discussed details on the mask in the part 2, so you can have a look on the video, the part 2. So now we borrow 1 bit for subnetting, 1 bit for subnetting. So that we had 24 bit previously the network address. Now we borrow 1 more bit. So now the network or the prefix length is 25. So network address 192.168.1.00000, and the mask is 255, 255, 255. But when we take 1 more bit for the network, then our mask will also be changed, right? So if we borrow 1 bit from the host bit, so in binary we can use 0 or 1 for that bit. So we are getting 2 networks, and so 2 subnetworks, and our subnet mask for these 2 new subnetwork is 255, 255, 255, and we borrow 1 more bit, and that 1 more bit should also be 1. So all the 8-bit 1 is 255, another 255, another 255, and 1. All the 7-bit are 0. That means 128. So the network mask is 255, 255, 255, 128 for our first network. So the first network is 192.168.1.0, and prefix length is now 25. Previously it was 24. And the second subnet 1, is from this subnet address. So if we convert this to the binary to decimal, we'll get again 192.168.1, and this 1 and all the 7 bits are 0. That means 128/25. So the prefix length is 25, and the mask is the same mask, so 255, 255, 255.128. So that's why this type of subnetting is called equal size subnetting. And in the next video, the video number 4, we will discuss more details on variable length subnetting, VLSM. But today we will discuss only on the equal size subnetting. So when we clear the equal subnetting, we understand the equal size subnetting very well, then we will go for the variable length subnetting. So in equal size subnetting, why it called the equal size subnetting? Because the subnet masks for all the subnetworks are the same. So you can see the prefix lengths, both of the network is 25, and the subnet mask for both of the network is 255, 255, 255.128. So let's do more analysis on the networks. So let's discuss again the subnet 0. So subnet 0, the network 192.168.1.0/25, or prefix length is 25. So now we have the 2 networks. So one is 192.168.1.0/25, and another one 192.168.1.128/25. So in subnet 0, what is the network address? Network address is 192.168.1.0, and all the 7 bits are 0. So if all the 7 bits are 0, that means the network address is 192.168.1.0, because now all the 8 bits are 0. So this byte is also 0 in decimal. And what is the broadcast address? So again, so the first or the leftmost bit of the rightmost byte is 0, right? And then all the other 7 bits are 1, so which is broadcast. So all the 7-bit 1, that means 127. So 192.168.1.127 is the broadcast address. So now we know the network address and broadcast address. So what are the usable IP addresses? So the usable IP addresses, that means the first host address or first usable IP address is one more than the network address. So the network address is 192.168.1.0. So the first usable host address or first usable IP address is 192.168.1.1, and the last usable IP address is one less than the broadcast address. So the broadcast address is 192.168.1.127. So 1 less than 127 is 126. So the range of the usable IP address is 192.168.1.1 to 192.168.1.126. And the same for subnet 2, that means the subnetwork or subnet 1. So in subnet 1, the network address is 192.168.1. So the borrowed bit is 1 and all other 0, that means 128. So this is our network address for subnet 1, and the broadcast address is all the host bit are 1. So if all the host bit are 1 and the bit we borrow, that is also 1, so that means it is 255. So the broadcast address is 192.168.1.255. So now what are the usable IP addresses? The first host and the last host IP addresses. So again, the first usable host or first usable IP address is one more than the subnetwork or network address. So network address is 128. So the first usable IP address is 129, and the last usable IP address is one less than the broadcast address. So the broadcast address is 255, and last usable host address or last usable IP address is 254. Okay. So let's calculate like the way how we know how many numbers we can have for number of subnets. How can we find the number of subnets and number of hosts? So to calculate the number of subnets, so we can calculate based on the number of bits we allocate for the subnet. So if we allocate 1 bit or we borrow 1 bit for the subnets, so we will get 2 to the power 1. So the 2 subnets. If we borrow the 2 bits for subnet, then we will get 2 to the power 2, 4 subnets. If we borrow the 3 bits for subnet, then we will get 2 to the power 3 subnets, which is 8 subnets. And to calculate the number of hosts, so if we are using 7 bits for the host, that means 2 to the power 7 minus 2, so 126 is the usable IP address or usable host address. So we are subtracting 2 because we are not considering the network address and the broadcast address. So these two address, other than these two address. Okay, so 2 to the power 7 minus 2. So if we are using the 6 bit for host, then 2 to the power 6 minus 2. If we are using the 4 bit for the host, that means 2 to the power 4 minus 2. So number of hosts we can have each of the subnetwork. Let's look another example. So consider 192.168.1.0/24. This is our initial network address, and we want to make it 4 subnetworks. So to make 4 subnetworks, we need to borrow the 2 bits because 2 to the power 2 is 4. So we can have 4 subnets. So we are borrowing the 2 bits, and these 2 bits could have all the 0, 0, 1, 1, 0, 1, 1. So this is how we actually getting the 4 subnets. And we said the borrow the 2 bits, that means now the prefix length is 24 plus 2. So the 26 26. So now the prefix length is 26. So what is the mask of these new subnetworks? So the mask for new subnetwork is, so first 3 byte are the 255. Then we borrow 2 more bits. So these 2 more bits should be again 1. So 1 and 1. So if both of them are 1, that means this is 1 and all at 0 is 128, and this is 1, then 64. So the new subnet mask for these 4 subnets is 255.255.255.192. So we get the 4 subnetworks, and also we have new subnet mask for all the 4 subnetworks, and all of them has the same length, 26, same mask. That's why we call it equal size subnetting, right? So this is a network, the same network, so you can assign the 4 different networks in your network, in your physical network, right? Now let's look another example, or the last example. So consider we have a network 172.16.0.0/16 network. So the prefix length in this network address is 16 bits, and we want to create 100 subnets. So to create the 100 subnets, how many bits we need, or how many bits we need to borrow for subnets? So the formula is 2 to the power s should be equal or greater than 100. So to get this, if we find the 2 to the power 7, which is 128, and 128 is greater than 100, and 2 to the power 6, which is 64, which is less than 100. So we cannot use the 6 bit, right? So we have to use the 7 bits, or we have to borrow the 7 bits to find or to get 100 subnets. So 172.16 is our initial network address, and on top of that we borrow 7 more bits from the host part. So if we borrow the 7 more bits from the host part, so the 16 plus 7, which is 23. So the new prefix length is now 23. And now we can get the number of subnets is 2 to the power 7. So these all are the subnets: 172.16.0.0/23, 172.16.2.0/23, 4.0/23, and the gradually 254.0/23. So what is the subnet mask for all of this network? So the new subnet mask is, so the 16 bit was the previous network address, so that means the 8 bit all are 1, so 255, and new 7 bit is all are 1, so this 7 bit is 1, and the last bit is 0, and remaining part is 0. So if the 7 bit are 1, so you can find, if you add them, I showed this in, I believe, the IP address part 1. So the new subnet mask is 255.255.254.0 or /23. So all these subnetworks, so 128 subnetworks has the same mask, 255.255.254.0. So this is the subnet mask. And the host, so how many hosts we can have each of these subnetwork? So the remaining number of bits is now 23 is network address. So we have 9 bits remaining, right? So the 8 bit from the last or the rightmost byte, and 1 more bit in the second rightmost bit because we borrow the 7 bit. So we have, or you can say 32 minus 23, so which is 9 bits for the host. So 2 to the power 9 minus 2, which is 510. So each of the subnetworks, each of this subnetwork could have 510 host or 10 IP addresses, 510 usable IP addresses. Watch this video or equal size subnetting. It's very straightforward, so you can watch the video from beginning to end, and you will find the subnetting is easy. And in the next video I will talk about the variable length subnetting, which is little bit more tricky. But if you watch the video, if you watch my next video, and the variable length subnetting or VLSM will become also very easy for you. Thank you very much.